Good morning all. Today I'm going to program the PIC microcontroller on my PWM5 through-hole board in circuit. So on this solar charge controller PCB, I put a 6-pin Icsp header. Now Icsp stands for in-circuit serial programming, and that means that I can program the chip using this PIC-Kit2 programmer, and that simply plugs onto there. Now if you're thinking, Julian, you've put that header array on the wrong way around, you meant to have the plastic down against the board. Well, I figured that it would be easier to remove that plastic after I've programmed the chip, just by sliding it off, and then I can simply lift these pins out one by one by desoldering them, because I don't think I want that there when I package this thing up in its weatherproof housing. So in circuit serial programming of the PIC chip, if a PIC chip is empty, you need to put the program in it, and that's done by the programmer. But of course it has to send the program in serially on 2 pins, clock and data. But this programmer also supplies VCC in case there's no VCC on this board, which of course there isn't at the moment. It's got no wires connected to it. It also has a ground connection, and it also has to provide the programming voltage, which on this chip I think is something around 13 volts. So get on with it, Julian. Plug in the programmer and program the chip. Well, it's not that straightforward, because the programming rules, it's more really circuit rules. They say that you've got to be very careful what's connected to the pins of the chip which are used for programming. Because remember, the pins of a microcontroller these days have multiple functions, and one of those functions is programming. If you have certain components connected to those pins, and of course your circuit might need those components connected to those pins, you might have a problem, because it might interfere with the clock and data signals going into the chip. So what are the rules? So here's a document from Microchip, in-circuit serial programming, Icsp. Let's take a look at the first page and what it says. So all mid-range devices can be in-circuit serial programmed, while in the end application circuit, this is simply done with 2 lines for clock and data and 3 other lines for power, ground, and the programming voltage. And here, the device is placed into a program verify mode by holding RB6 and RB7 pins low while raising the M clear VPP pin from VIL, something low, to VIHH, something much higher. And I think that's the 13 volts, or it might be 13.5, I can't quite remember. See the programming specification. And having VDD at the programming voltage at the chip's power pin, I presume. RB6 is the programming clock, RB7 becomes the programming data, their Schmidt trigger, and RB7 is bidirectional because it needs to take data in, and then of course it needs to send the data back out in order for the programmer to verify that the chip was programmed successfully. The application circuit must be designed to allow all the programming signals to be directly connected to the PIC micro MCU. Figure down here shows a typical circuit that is the starting point when designing. Now we've got isolation of the M clear stroke VPP pin from the rest of the circuit. Well, on my charge controller it is completely isolated, and I've run it out to pin 1 of the header, so that's absolutely fine. Loading of pins RB6 and RB7. Now that's an issue because they go off to various places. I can't quite remember which one's which, but one goes to the ADC components. So let's have a look at my circuit diagram. It's got a 220 puff to ground on the ADC input. It's got a 20k to ground and an 82k to VCC. And the other pin, I've actually connected the LED to that pin with a 150 ohm resistor. So can we use that as a programming pin when it's got an LED connected to ground? Is that going to load the programming pin in such a way that it can't program the chip? Dunno. So here's the Icsp diagram. Now they've shown this as 5-pin. Mine's actually 6-pin. There's an extra pin which is not used. They've got VDD coming in through a resistor. I've got a feeling that's so that when the programmer raises VDD on the chip, if you've got enormous amounts of capacitance on your circuit, that could come up so slowly that there's a problem programming. I think that's what that's for. The programming voltage needs to have, well, in some applications you would tie M clear to this sort of network. I haven't bothered. I've left it completely open, relying on the internal pull-up when you put it in M clear mode. So my VPP pin is actually unencumbered. I can proceed with that, no problem at all. Ground, of course, is just connected to ground. Now they've shown isolation circuits between the microcontrollers, these two pins, and your circuit. So you isolate your circuit to enable programming with the programmer. But what are they asking for? Are they actually asking me to, when I program this chip, to put little header links in here, pull the header links out so that I can program the chip, and then put the header links back in so that my application circuit actually functions? I can't do that. I haven't got space for that, and they'd be a point of unreliability. No, that's not going to happen. Now, this document talks about RB6 and RB7, which are port B bits 6 and 7, but actually it's slightly different on my microcontroller, because you can see here that on the 12F683, which has only got 8 pins, of course, that GP0 is Icsp DAT and GP1 is Icsp clock. Now GP0 I'm using actually is AN0. Let's just mark that, because I'm using that as the analog to digital input to measure the voltage of the battery. And GP1 I'm actually using as a, yes, I'm using it as a general purpose output, so GP, because that's driving the LED. So let's draw the circuit that the programmer is going to have to contend with certain components on these two pins. So first let's draw my chip. I'll draw it over here like that. We've got VPP, that is pin 4. We've got VDD, that is pin 1. We've got VSS, or ground, which is pin 8. And then we've got GP0, well, I'll call it AN0 because that's how I'm using it. AN0 is pin 7, and GP1, which I'm using actually for the LED, is pin 6. So that's what I'm connecting my programmer to. I'll draw the programmer over this side. So I've drawn a ground in here and connected it to VSS. Now on AN0, I have got a capacitor to ground, 220 picofarads. I'll draw the numbers in later. I've got a resistor to ground, 20k. I've also got a resistor to VDD, so I'll draw that there, because that's the potential divider for my analog to digital converter. So 82k up to actually it's to VBAT, so it doesn't quite go to the 5 volts VDD, it goes off somewhere else. Actually, I wonder whether there is a connection through there. Well, there might be through the diodes, I don't know. So I'll put a big asterisk here because it doesn't actually go to VDD, it goes off to the positive of the battery, which is the input of the voltage regulator. What else have I got? Well, on GP1 I've got an LED, so coming off here I've got a resistor and then an LED. Now it's a blue LED, so it's going to have a forward voltage of 3 and a bit volts, and that's going to be an issue possibly for the programmer. Let me just check which one it is. GP1 is Icsp clock, so the programmer is going to be waggling this line furiously with the clock signal, attempting to force data in on this pin. Is it going to be able to bring this line high enough that the data actually shows a logic 1? It'll be able to bring this down to ground, but it won't be able to take it up to 5 volts because this LED will act as a clamp. I should mark that with the arrows coming out. It's going to clamp the voltage at about 3 point something volts. So is it going to work? And then when the data is flowing into the chip on the Icsp data line here, analog input 0 as I'm using it, is this 220p capacitor going to slug that data signal? I don't quite know how fast this thing runs. I'd have to look up the specifications for the frequencies involved. And these two resistors, 20k and 82, I can't see those having a major impact because they're quite high values. So what I'm going to do today is I'm going to make up a brand new one of these boards. Here's a brand new board. It's got my J tag on it. J with a smiley. Incidentally, winners of the competition for these boards have been selected, and I have started actually making up the packages. Here's one of the packages. You can see the board is in there at a jaunty angle. It's taken me a long time because I'm going a bit over the top and I'm really slow at admin, but they are on their way. Yes, I'm going to make up a new board with just the microcontroller and the header connector on. Initially, I will put the resistor under the microcontroller because I won't get a second attempt at that. Then I'll fit the LED and see if I can program programs into the chip with this LED effectively clamping the clock line. And then I'll fit the 220 picofarad capacitor onto the data line to see if that causes problems with getting data into my PIC chip. Now you can probably tell by the fact that I've got a header on here and this is populated that I've already tried this, so I know the outcome, but let's go through the motions. Right, first things first, I need this 150 ohm resistor that is in series with the LED. I'll put the resistor in, this is a 150 ohm 8th watt, and then I'll put the microcontroller in over the top of it because the resistor sits under the microcontroller there. And then I will program the microcontroller with a little blinky program just to make sure that it will program. And then I'll add the LED in, and that really will clamp that line, and we'll see whether we can still program it. So let's put this little 150 ohm resistor in, just bend that approximately right, feed it through these holes, and I haven't switched the iron on. Let's switch that on and then solder that in. So up until yesterday, I had never attempted an actual in-circuit serial programming of the chip in my application circuit. In fact, I don't think I've ever tried in-circuit serial programming at all. That's the ground pin, so that's really taking some time to tin. Also, the legs of these LEDs, these resistors, are very tarnished because they're very old. So this is my first ever attempt to in-circuit serial program with components connected to these two pins and not isolated. You're meant to isolate this stuff. I'm going to attempt to do it without isolating it. So I need a microcontroller. These are pre-programmed with slightly earlier version of the firmware, but it's really not that much different. And I've got my 6-pin header, which I'm going to solder in the wrong way around. Let's get those two on. So there's the chip inserted into the board, sitting over the top of that 8th watt resistor. It does sit a little bit high, as I think we saw in the last video. Right, let's solder that one, and then I'll get the header on there. So I'm going to solder the header just sitting down on here. That puts it at about the right height to plug into the PIC kit 2. So I'll do that and I'll solder from the top. Now I can't remember which one's ground on here. I won't solder ground because ground's going to be the hardest one to solder. That one's gone on. I think the ground's third in, so let's solder this one. Right, that's got the position set for the height of that thing, so I'll do the rest of the soldering underneath. Now of course the other thing I need to do is to push this plastic thing as far back as it will go. That's quite tricky, but I'll just ease that back just to give myself a good chance of getting the programmer connected on there. Is that going to connect nicely? Oh yeah, that's got enough depth to connect the programmer. Right, so I just need to, oh, here it is. Let's plug in the program into my PC. And that's powered on, power from USB. That's going to provide 5 volts to the microcontroller. It's also going to provide the 13 or whatever it is volts for the programming voltage and send out the clock and data signals to the chip. Now at the moment, because I've only got the resistor in there and not the LED, these lines are not impacted by my components, so programming should go smoothly. Now the other thing I was doing yesterday, if I lift this up, is I was using my Logitech webcam, this one, and trying to get some settings for OBS so that I can put the webcam here, have this and the screenshot of my software all in shot at the same time, and I think I've managed it. So I have run up MPLAB IDE version 8.92. I've got my flashing LED program. It's a slightly odd one. It uses the watchdog timer and sleep. And I've made the text really big so you can see that. I don't need the workspace. I don't even need the output window for the moment. So let's... oh, I didn't mean to do that. I've changed the size of that. How do I change it back? Like that. Excellent. And let me just check OBS to make sure it's putting the image of the camera above that. Yes, it does seem to be. So all's good. Incidentally, if the sound is a little blurred or muted, that's probably because I'm not at the front of the camera. I'm at the front of the camera now, but I'm behind the camera. I'm actually using the microphones in the Logitech to record sound. Okay, the first thing I want to do is go to Programmer, select Programmer, PIC Kit 2. Does anything happen? Yes, it's turned on the target light, and the output is telling me that it's initialized the PIC Kit 2. Target power not detected. That means there's no actual power on this board, so it's supplying power. It's found a 12F683 and we're ready to go. So let's get rid of that output window. So now what I want to do is project quick build my flash program, make sure there are no errors in there. I've got a couple of messages, but the build succeeded. That's fine. Let's put this back to the front and let's program the chip. Actually, no, I want this. And it said erasing the target, programming program memory, verifying program memory, blah, 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 setting mclear to a 3-state PIC Kit 2 ready. So that should be running my flashing LED program, but of course we can't see a flashing LED because there is no LED. So I think it's time to solder one in. But just before I do that, I'm going to go to Programmer and I'm going to switch VDD off. Now you should see on the PIC Kit 2 here that target light will go off. So let's set VDD off. The target light's gone off, so VDD has been taken off this board. So it's fine for me to now disconnect this and we'll solder that blue LED in. Right, soldering iron warming up again. The flat on the LED there goes to the bottom here. There goes the LED in. So now we are going to have effectively a voltage clamp on this clock line as it goes into GP1, which is program clock. Some solder here, and let's do this on my little board here. Press that down on there. Solder that LED in. Am I in shot? Yeah, just about in shot there. That goes in like that. Now the question is, I'll power it up first. In fact, I'll do that right now. Let's cut those off. Take that away. Plug this into... Now, of course, there's no power on there at the moment, so I'm just going to go back to the PC and Programmer, set VDD on. Now VDD has come on, but it's holding the chip in reset using, well, it's the same pin as the programming voltage. It's also the master clear pin, so it's just holding that down, holding the chip in reset. So I'll release that. Released. And there it is. Flashing LED. So the chip was programmed successfully with the LED not in circuit. Now the question is, can I program the chip successfully with the LED in circuit? Let's give it a try. Okay, this is where it becomes a bit more visual because we can actually see what's happening. So in this program, I have a number here, 0, which is a fast flash. If I change that to 02, it will slow the flash down. So let's do that. So I'll save that file, quick build the project, which reads the source code and creates, assembles it into some hex and binary for the chip. And now I'll program the chip, and this should program the chip with the slightly modified program. And if it successfully programs, that LED should flash at half the rate. So let's program that. and it's flashing at half the rate. That is awesome. So yes, you can program the chip with that LED. Not sure whether this will be visible, but with that LED across the clock line with the 150 ohm resistor, effectively clamping this clock line at about 3 and a bit volts. But it's enough of a high voltage for the chip to see it as a logic 1, and so it successfully programs. Good news! So that's excellent. I can program it with that LED in circuit. Now the other component that's given me a little bit of cause for concern is this 220 picofarad capacitor. It's quite a low value, but at high frequencies, and as I said, I don't know what the frequency of data going in and out of the chip is. It's probably quite fast. This could slug this line quite considerably. I'm not too concerned about the 82K and the 22K, and I'm not going to fit them today because I don't actually have them. I'm waiting on some eBay deliveries. But I'm going to put that 220p in on the data line. So we'll have the LED clamping the clock line and the 220p slugging, or what would it be, low pass filtering the data line. Depending on the impedance of the data pin output, it will depend on the frequency that this will impact. But let's get this bent into shape because it's got to fit into a 2/10 pitch spacing, solder it in and see if we can still program the chip. I'll go back to the fast flash for that. Let's get the soldering iron. So bending the 220 puff into a shape which will fit into the hole. I really wish I'd done a 1/10 spacing on that. I'll just go to my software and turn VDD off on the programmer so that it's got no VDD. Take that out, put my capacitor in there, and let's get that soldered. So if it can successfully program the chip with both the LED and the capacitor in circuit, and spoiler alert, oh no, I shan't spoil it. That would be silly to spoil it. This is the ground pin. I do have a lot of trouble soldering the ground side of these components. It's these spokes, they're too fat. I need to thin my spokes down. Okay, we're done. That can, I need to chop these legs off. Where are my cutters? Here they are. Chop these two capacitor legs off. Don't leave them on my mat to short stuff out. Right, plug this back in. Put power to it, which I can do by saying programmer set VDD on and raise the clear line. So that's doing the slow flash. Right, let's go back to OBS and see if we can program the chip again. So what I need to do is change this back to 00 for the fast flash. I'll save my file. I'll build a new hex file which is going to be programmed into the chip. That has built successfully. Right, so this is a slow flash. We're expecting when I program it to go to a fast flash, and it does. So that means, and now I really can spoil it, that it successfully programs with that 220 picofarad load on the, oh, which one was it? The data line, and with this sort of 3 and a bit volts clamp on the clock line. So all is good. So the last thing to do really, this is a very short program, as you can see. There's the slider bar, so there's not much to that. Let's bring in this program, which is the actual charge controller firmware, and this is a much longer program, as you can see from my slider bar. So let's project quick build that, because I just want to see whether it will successfully program with a much longer hex file. So the build succeeded on that. Let's program it. That's programming, and that looks like it's the right response. You can see we're getting brief flashes. Now brief flashes on here mean that it's detecting that the battery voltage, of course it's got no potential divider, so it's not really measuring anything, is less than 11 volts. So that's certainly the right response. And if I hold that in reset and rerun it, you see the 2-second LED on period, which it's actually something to do with the switch to enable and disable the LED, but I'm taking that out, so I'm not going to make a big thing about that. And this is actually doing what the charge controller does, which is measure battery voltage. It can't at the moment, but it's just saying that if there were a potential divider here, the battery voltage would be less than 11 volts, and therefore it's flashing this regular flash. So that's running. So what that means is that the programmer is able to successfully program this chip with the capacitor and the LED in circuit. So the upshot of all this is that I now know that I can successfully program the chip with all the other components on the board, and I have actually successfully programmed this chip with all these components. I haven't quite finished the assembly of this unit. So it means you can put a blank chip on the board with all the other components, program it in circuit. Oh, that's not a good idea. Program it in circuit, and then the unit is ready for use. And of course I'll be building 3 of these because I've got those 3 solar panels on my power fence, my power wall outside, with the 3 Trojan batteries. So I will, in the next video related to this project, I will continue to do the assembly of this board and 2 other boards until I have 3 working solar charge controllers. Cheerio.